Exponents are one of those subjects that flummox all sorts of people because it can be really confusing how the properties work with them. Now, before we start, exponents are just a shorthand notation so that you don't have to write 2 times 2 times 2 times 2 times 2 times 2 times 2. It gets confusing. You have to count every time and say, I wrote 7 2s. And so we agreed, instead of writing 7 2s, I'll write a 7 up and to the right of the 2. This symbol will just mean, imagine I wrote 7 2s. 2 times itself 7 times. So the definition of exponent, when the exponent is an integer, is a to the m equals a times a times a times a m many times. That definition, if you can just hold on to it, will get you the key exponent properties. We'll talk about 5 properties in this video. Okay, the first one is that a to the m times a to the n is equal to something. Now, if you think about what this symbol means, it's really rather obvious. Imagine if I had a to the third times a to the second. So, by definition, that's a times a, and you count it up and you say, that's 5 a's. What did you do? You just added the exponents. Now, these two terms are being multiplied, but what you did was you added m and n to get a to the 5th, because you were reading the total list of a's. Similarly, if I had a to the m over a to the n, what's happening here is, think about it, if I had a to the third over a to the second, you'd have a over a, and you'd cancel a's. So you'd end up with 1a left. What happened? Well, you had 3, you took away 2. That's the definition of subtraction. So a to the m over a to the n is a to the m minus n. Even though you're dividing these outputs, you're subtracting in the exponent. Finally, what happens if you have a to the m to the n power? Yet again, you run back to the definition. What would happen if I had a to the third to the 4th power? Let's see. Well, a to the third, by definition, is a, and I've got that 4 times. In other words, I'm going to write that 4 times. So I'm going to write a. I guess that's 12, right? You've got 12 a's. I mean, it's pretty simple what that is. What was the operation you did there? Well, an exponent to an exponent is simply multiplication. So those are 3 really nice rules that help you to understand how exponents work. If it was just those 3 rules, life would be grand. Unfortunately, there are 2 other rules about when the bases are different. See here, the base was the same. This number is the base, that number is the exponent. What happens though if I have a to the m times b to the m? Well, here, when you multiplied, you added the exponent. What happens here? Don't try and blindly hold on to a rule. Hold on to the definition of the symbol. What would happen if I had a to the third times b to the third? Well, by definition, that would be 3 a's and 3 b's. So if you wanted to, you could use commutativity of multiplication, and you could write ab, ab, ab. You can see that you've got 3 a's and 3 b's, so that's really 3 ab's. So here's the catch. If the bases are different, but the exponents are the same, you multiply the bases. The exponent stays unchanged. You could probably guess where we're going with this. If you have a to the m over b to the m, what's going to happen here? Well, you should anticipate. We're going to go to the definition. Let's just do a little example here. A to the third over b to the third. What's that going to be the same as? A over
B.
Well, you could always put parentheses there, just reassociating and then moving the division. So you have A over B to the third. So what you have there is you have A to the m over B to the m is A over B to the m. Now these are the basic exponent properties. If you can use those through all sorts of examples, that'll help you a lot.